So a single conservative force Fx acts on a 1 kg particle that moves along the x-axis. The potential energy Ux is given, and this is the energy associated with the force Fx, and this is given as minus 4x e to the power minus x over 4, like that, sorry. So we need to find another information is given that at x is equal to 4 the particle has a kinetic energy of 2 joules. So we need to find what is the mechanical energy of the system. So mechanical energy is, of course, mechanical energy, if we write it, mechanical energy is potential energy plus kinetic energy, sum of that, and that will remain constant. So at x is equal to 4, kinetic energy is given, which is 2. We need to find what's the potential energy at x is equal to 4, x is equal to 5, sorry. So u5 will be minus 4 into 5. I'm just substituting x is equal to 5 in this equation, so that's minus 5 over 4. So we get minus 5.7 joules. That is the potential energy at x is equal to 5. So mechanical energy will be, kinetic energy is kinetic energy is 2 and potential energy is minus 5.7. So mechanical energy will be the sum, which is minus 3.7 joules. So this energy will remain constant throughout. Then the question says that plot ux as a function of x for x is equal to 0 to 10, and on the same graph plot the mechanical energy of the system. And using the graph we need to find the least and the greatest value of x of the particle that value of x, maximum and minimum value of x that the particle can reach basically, and find the maximum kinetic energy of the particle and the value of x at which that occurs. So here is the plot. This one is minus 4 x e to the power, so that's the ux basically, and so this is ux, and this one is the mechanical energy. This is constant, and what happens is this is the value here, minus 3.7 basically joule. So we have to find what is the minimum and maximum value of potential energy, or maximum value of x that the particle can reach. So that will be, of course, this value and this value, because if the potential energy is becoming less negative there, then in order to maintain this mechanical energy, the kinetic energy has to be negative, which is not allowed. Let's say we take a potential energy of this much, where the potential energy is 3, which is, or maybe let's say here when the potential energy is 2, to make it more obvious, we are choosing a value far away from this point, which is maybe somewhere here, 2. So potential energy is here minus 2, sorry. So in order to maintain kinetic energy of minus 3.7, sorry, the mechanical energy minus 3.7, the kinetic energy has to be negative as well. So that is not possible. So what will happen, we can allow only positive kinetic energy. Kinetic energy is half mv square, v square, so it will be positive. And for that to happen, we can allow only potential energy of this part. So this is the value, these two are the minimum, least and maximum value of x that are allowed for the particle. For that value, the mechanical energy will be, the kinetic energy will be still be positive to maintain this value of mechanical energy, which is minus 3.7 joule. So this is what we get there. Then this last part of the question is find the maximum kinetic energy of the particle and the value at which it occurs. So again, the value of kinetic energy is the potential energy minus mechanical energy. That will be the value of kinetic energy. That happened earlier as well, because it was minus 5.7 and then minus 3.7 which was at x is equal to 5, that gave 2 joule. Actually 2 joules was given. That's how we got 3.7 minus 3.7 joule as the mechanical energy. But it's always potential energy minus the mechanical energy will be the kinetic energy. So we can see this distance where it maximizes somewhere here, which can be said, if we look here, I don't know, maybe 5.9. it looks 5.9 here, the value of the value of potential energy. So if potential energy is 5.9, which is the maximum value, minimum value of potential energy, and then so maximum negative, basically ME, so that will be 5.9 minus 3 points. So this is minus 5.9 minus 3.7, which will give me what I did wrong there is actually mechanical energy minus potential energy is the kinetic energy, sorry. So yeah, that's what it is. So mechanical energy minus potential energy is the kinetic energy, and here what happened is actually this will give a negative 2, actually minus 3.7. so sorry, there was a mistake there. So basically that is because of course mechanical energy is potential energy plus kinetic energy, so kinetic energy will be mechanical energy minus potential energy, and that is what happened earlier at when x is equal to 5, minus 3.7 minus 5.7, which gave us 2 joules. Earlier what I did when I did the mistake, it was this minus that would give a negative kinetic energy, which is not possible. So anyway, it should be mechanical energy minus potential energy. And what happens here is, of course, again this is a mistake there, so it should be, so basically it's still the distance same, this distance, but both of them are negative. So of course this one minus that one will give the positive value, this one minus that one, mechanical energy minus potential energy. So mechanical energy minus potential energy will give the kinetic energy maximum. We are trying to maximize it, so when this is the maximum possible negative, so this one is minus 3.7 and this one is minus 5.9, which gives us 2.2 joules. So this is the maximum value of kinetic energy, and where it happens, that's the final part of the question. At what value? We can look at the graph here, and I don't know, it's probably somewhere at 4, x is equal to 4 if we say approximately. So x is equal to 4. At that point the maximum value of kinetic energy happens, which is 2.2 joules.